The western region of the United States is home to a sleeping behemoth. It occasionally stirs but haven't woken up from its sleep yet. But when it does, it could wreak havoc that hasn't been witnessed before. Almost 640,000 years ago, a volcanic eruption in that part occurred, and it was 8,000 times more than St. Helens emission in the 1980s. The authorities of Yellowstone National Park have found an identified piece of magma that has started to pulse violently. The public has been wondering about the potential explosion of a ticking time bomb and whether it may erupt in this lifetime. Let's dive further into the discovery of this pulsating magma and the possibility of its eruption, like the breathing of a large sleeping mammoth. The woodland preserves of Wyoming, Idaho, and Montana. The surface has been rising and falling due to heat and pressure. The volcano is located in the northwestern area of Wyoming. The ground expands as the magma pours into the magma chamber, and the ground collapses as the magma begins to cool down and solidify. The ground rose by 25 centimeters, 9.8 inches between 2004 and 2009, according to research that has been tracking this rise and fall since 1923. But in 2010, the Earth's surface began to sink. The researchers have been speculating about the possible eruption of the volcano, and concerns have been raised from the Earth's genesis 4.6 billion years ago until around 541 million years ago. The Precambrian period covered the Earth's history. Yellowstone and nearby mountain regions are home to ancient rocks. Mountain building processes created the Rocky Mountains. But the mountain building, volcanism, faulting, and glaciation created the Yellowstone area. The West separated around 30 million years ago, forming the contemporary basin and range topography. Volcanism began near Nevada, Idaho, and Oregon, with eruptions moving from southern Idaho to Yellowstone. The North American plate shifted over a magma body in the southwesterly direction, so the Yellowstone area shifted closer to the magma around 2.1 million years ago. Yellowstone is the region where the magma is the closest to the Earth's surface. The thermal convection of the mantle makes these magma rocks, which are melted by magma plumes. The process leads to volcanism as the heat gets transferred from the depth of the mantle to the crust. The volcanic hot point beneath the border of the Yellowstone area melts from the heat, making to magma chambers and resulting in a volcanic eruption. Earthquakes and gases escaping to pollute the atmosphere. The surface above the magma chamber dived as it emptied and formed the first of Yellowstone's 3 calderas, one of the greatest volcanic eruptions ever known to man. Yellowstone volcano is not the only supervolcano in the world, and Earth has experienced multiple supervolcanic eruptions throughout history. Most of the continental United States is covered by volcanic ash, debris, and magma from previous volcanic eruptions. The caldera and Yellowstone share the same name and the same fate. The caldera tilted towards the south, causing the lakes to sink and the trees to stand in the water. The magma and hot fluids make the bubbling pools home to the park surrounding the caldera. A region around Yellowstone has been rising and falling with its unknown origin. However, a recent scientific study at Cascades Volcano Observatory suggested that Norris Geyser Basin could be the origin, and they did not predict it overnight. A tracking system through satellite-based radar and a GPS system was used to track the origin of magma. The geology of Yellowstone is intricate and complex, making the underground exploration even more difficult. However, the scientist, Michael Polland, stated that they are beginning to understand the dynamics of Norris. An incredible finding was 3D imaging of a massive magma plume beneath Yellowstone responsible for carrying lava and heat. Yellowstone's magma chamber is a skewed magma plume that feeds the shallower magma system coming up the Earth's surface. This disapproves the past claims that Yellowstone doesn't have a plume. The Norris Geyser Basin is the oldest thermal area in Yellowstone. with a temperature of almost 459 degrees Fahrenheit. The Yellowstone Volcanic Observatory was established in 2001 to improve scientists' capacity to monitor reactor changes in Yellowstone's activity. The observatory is an extended instrument-based monitoring program that tracks earthquake and volcanic activity near Yellowstone National Park. The team also questions whether the recent record-breaking number of eruptions in Steamboat could be related to the buildup of magnetic fluids in the 1960s and early 1980s. The Steamboat geyser experienced similar activity spikes, possibly related to base and breathing cycles. The connection between magma intrusion and Steamboat's hyperactivity is best circumstantial, but the timing does align. A 3.3 magnitude earthquake struck close to Lewis Lake in the southern region of Yellowstone National Park on August 31st this year. There is extremely little chance of a Yellowstone eruption at any site, but if speculating a minor eruption, the results in lava flows and a normal volcanic explosion. A large-scale volcanic eruption would significantly impact the world's climate, with sulfur aerosols released by volcanoes reflecting sunlight back into the atmosphere, lowering temperatures. No indicators of an impending eruption are found, but the likelihood of Yellowstone exploding in any given year is very high, with the odds of exploding at least 4% according to the USGS. This is lower than the likelihood of being struck by a civilization-destroying asteroid. It is unlikely that a volcanic eruption may occur in the Yellowstone area in the near future, but the chances of a supervolcanic eruption in the coming centuries are low. The impact of a supereruption in Yellowstone would be catastrophic, with potential effects including widespread destruction, debris in the atmosphere, and global climate change. The Yellowstone National Park was home to indigenous people. Over 11,000 years ago, the park has attracted commerce due to its natural resources, such as the source of an important trade known as obsidian and amorphous volcanic glass. One tragic event at Yellowstone occurred when a victim fell into the hot spring. The victim's sister was recording the video on the phone when the victim fell, but the park authorities refused to share the video publicly. The park is not the only place where volcanic activity is high. A place in Indonesia, Krakatoa, is still active and can erupt again. The last eruption claimed the lives of 36,000 people, proving to be the deadliest volcanic eruption. Warning signs like billowing smoke and small, seemingly insignificant earthquakes were not ignored, but people included the events and festival celebrations instead of fleeing. The eruption was so loud that it was heard 2,800 miles away in Australia and 3,000 miles away on the islands of Rodriguez. The amount of ash and debris created flashes of superheated steam that moved at over 60 miles per hour, casting darkness that didn't go away for 3 days. Tamsin Mather, a volcanologist and professor of earth science at the University of Oxford, explains that most submarine volcanism is associated with continuously active volcanoes along the mid-ocean ridges where tectonic plates pull apart. One notable eruption is the Hunger Haiapai volcano in the Kingdom of Tonga, which caused a devastating tsunami that killed 5 people and sent ash tens of thousands of kilometers. Mauna Loa, the world's largest volcano, is poised to erupt right before us and can erupt again with potentially catastrophic consequences. Underwater volcanoes are difficult to study due to their inaccessibility in the water. Supervolcanoes are not the only threat to life on this planet. Some scientific studies suggested that more than 95% of the Earth's plant and animal species were wiped out by a volcano that erupted 150 million years ago. Some scientists claim that the dinosaurs were wiped out 65 million years ago, not because of some asteroid hitting them, but rather by a volcanic eruption. The largest volcanic eruption recorded in 2018 was a giant skyscraper-size underwater volcano in the western Indian Ocean of Madagascar between May 2018 to 2021. More than 11,000 earthquakes shook the small island and French territory between Madagascar and Mozambique, Mayat. These low and high-frequency earthquakes are associated with volcanic activity. In July 2018, the scientists discovered that Mayat was moving eastwards about 7.8 inches per year, which was recorded by GPS data. They installed global navigation satellites and ocean bottom seismometers around the island, too. Learn about the geological changes. Another largest volcano is Tamil Massif, comparable to the largest in the solar system. But the good news is the volcano went inactive and extinct as soon as it was formed, probably during the late Jurassic era. In 2012, a Harvard seamount exploded with a volcanic eruption half the size of St. Helens eruption. In the United States, an airline passenger spotted an enormous floating raft which was sent to a geologist to solve the mystery of the largest deep-ocean volcanic eruption on record. Underwater volcanoes are also of significant concern, as they cause tsunamis and can impact coastal areas. Underwater volcanoes such as Tamil Massif and the Harvard seamount can also have significant eruptions that can affect the nearby land and can impact climate globally. In October of that year, the NIWA research conducted a research investigate using an echo sounder and concluded that it was indeed Harvard which erupted. The scientists went to Harvard 3 years later to take a detailed look. The underwater robot, Rove Jason, was pre-programmed to follow a route set to take pictures of the volcano and to measure water chemistry. The volcanoes could be explosive or effusive. Volcanoes being explosive means that the volcanoes explode, while being effusive means that the lava flows steadily from a vent. The Hawaii Naputine eruption in 1600 caused the global climate to be affected. The Santa Maria eruption in 1902 was a violent eruption. The same goes for the Thera eruption in Greece. Despite the lack of human remains, scientists have been able to predict the eruption and evacuate the island on priority basis. The powerful Minoan civilization declined suddenly soon after the eruption, and the drop in temperatures caused by sulfur dioxide spouted into the atmosphere. The lethal combination destroyed every notable Minoan stronghold in less than 50 years. The powerful Minoan civilization experienced a sudden decline after the Thera eruption, causing tsunamis, cold, wet summers, and the destruction of strongholds. This led to a political vacuum, resulting in the warring city-state system of ancient Greece, which would dominate the Mediterranean and become a fundamental building block for Europe's history.